right, this is Unit 2 review day 2 on solving with logarithms and then doing word problems with logarithm formulas. So with solving, remember that's when you had to, one, get the base by itself. So like, for example, if it's an exponential like this one, you would have to make sure the exponential is by itself. Or if it is a log, you would need to make sure the log is by itself. Then you would convert to its opposite form. So like, for example, if it's in logarithmic, you're going to turn it to exponential. If it's in exponential, you're going to turn it to logarithmic. And then 3, solve for x. So for example, number 4, we got 4 to the x minus 3 equals 1/16. That one, the exponential is already by itself. So we go straight into converting it to its opposite form, which is logarithmic form. So that becomes log base 4 of 1/16 is equal to x minus 3. And log base 4 of 1/16, remember that's when you plug it in the calculator as log of 1/16 divided by log of 4. And so that's going to give you -2. So that's -2 equals x minus 3. And so the only step left to do is to solve for x, which is adding 3. So x is equal to 1. And that's your final answer there. Okay. Number 17, you've got 5 to the -4 minus 2x equals 625. Again, my exponential is already by itself because all of this is written as an exponent. So you can't move that anywhere. You have to go straight into log form. So that becomes log base 5 of 625 is equal to -4 minus 2x. Okay. And again, you'll do log base 5 of 625 in your calculator by doing log of 625 divided by log of 5. And you get 4 is equal to -4 minus 2x. And we solve for x by adding 4 to both sides. So that gives me 8 equals -2x. And then divide by -2. And x is equal to -4. And that's your answer for number 17. Okay. Number 18, we have 100e to the -0.6x equals 20. This one is not by itself because you have this 100 in front of it. So we need to get rid of this 100 by dividing it to both sides. So 20 divided by 100 gives me 0.2. So that's e to the -0.6x equals 0.2. And because we have it in e form, this means we have to turn it into natural log form. So that becomes natural log base e, which we don't write, of 0.2 is equal to -0.6x. And again, natural log, you can just simply type in the calculator. Natural log is right here next to your 4 button. So natural log of 0.2 is equal to -1.6. I'm going to round it to 2 decimal places. So -1.61 equals -0.6x, and then -1.61 divided by -0.6 to both sides gives me x is equal to 2.68. And that is your final answer for that one. Okay. Number 19, again, my exponential is not by itself, so I need to get it by itself. The first thing I need to do is move the 14 over. So that gives me 3e to the x equals 25. Then divide by 3. Now that's going to give me a really long repeating decimal, so I'm just going to leave it as e to the x equals 25 over 3. Because then I'm going to convert it to natural log form, which becomes natural log base e of 25 over 3 equals x. So you'll just plug in natural log of 25 divided by 3 to give me 2.12 equals x. And you don't have to solve for x because it's already by itself. Okay. Number 20, this is a problem that messed with a lot of people when we went over this. You just have to remember your log rules. Remember, exponents go where? to the front. So my 2 is going to get moved to the front first. Okay, now we divide by 2 to both sides. So that becomes log of x plus 2 is equal to 3. Now we convert to our opposite form. And remember, the opposite form of logarithmic is exponential. And the one thing here is, notice I don't have a base to start out at. If log does not have a base, it's understood to be 10. So that becomes 10 to the third is equal to x plus 2. So 10 to the third is equal to 1,000, equals x plus 2. Subtract 2 to both sides, which gives me that x is equal to 998. And that's my final answer there. Okay. Now number 21 number 21 is one of those special cases where when you have a log equals a log, remember the logs will cancel out when you have them equal to each other. So that just becomes x plus 5 equals 2x minus 3. And you just start solving for x. So I'm going to subtract x to both sides. So that gives me 5 equals x minus 3. Add 3. And that gives me that x is equal to 8. Okay. Last one on that page is I have 2 logs on the same side. When you have 2 logs on the same side, they do not cancel out. You have to combine them. And remember, that comes into our log rules, where when you add, that means you multiply. So that's going to become log base 3 of x minus 8 times x minus 2 is equal to 3. Now you need to multiply these two together. And remember, to multiply these two binomials, you have to do either FOIL or box method. So I'm going to show that work over here to the side. X minus 8. X minus 2, so that becomes x squared minus 8x minus 2x plus 16. Okay, so it becomes log base 3 of x squared minus 10x plus 16 is equal to 3. Now that we've combined it, we can now convert it into its opposite form, which is exponential. So that becomes 3 to the third is equal to x squared minus 10x plus 16. And 3 to the third is 27. And we're going to get this set equal to 0. Anytime you see an x squared and an x, you can't just solve for x without getting it set equal to 0 and factoring. So we're going to subtract 27 to both sides. So that becomes x squared minus 10x minus 11. Okay, now we factor. Remember, that means you have to find something that's going to multiply to give me negative 11 and add to give me negative 10. Well, that's going to be x minus 11 and x plus 1, because they multiply to give me that negative 11 and they're going to add to give me that positive 10. So that gives me x is equal to positive 11, because you take the opposite, and negative 1. Be careful, okay? Remember, when we take the logs, you cannot take the log of a negative number. So if I plug in 11 minus 8, that's still going to stay positive. But negative 1 minus 8 is going to become log of negative 9. So we can't have that. So my only answer is x equals 11 there. Okay, you cannot take the log or natural log of a negative number. So please remember that. And if I had only had one solution, if negative 1 was my only solution, that means the whole problem would be no solution at the very end. All right, next page, we've got some natural logs. And so natural logs, if the natural log is already by itself, like this first one is, you just convert it to your e form. And so that becomes e to the 4th power equals 2x plus 5. And e to the 4th power, you can just plug into your calculator. Remember, e is when you hit second and then natural log. So e to the 4th gives me 54 point, and then if I round this, that's going to become 54.6 equals 2x plus 5. And then we just start solving for x. So we're going to subtract 5 to both sides. So 54.6 minus 5 gives me 49.6. And then divide by 2, which gives me x is equal to 24.8. Okay? And then number 24 is like that last problem we did on the previous page where you have the natural logs on the same side, which means you need to combine them, okay? And so the log rules still apply. When you add, you multiply. So that's x times 2x, which is 2x squared equals 3. And so we convert to e form, so that becomes e to the third equals 2x squared. And we'll plug in e to the third in our calculator. So second natural log to the third gives me 20.09 equals 2x squared. Divide by 2 gives me 10.05 or 0.45 equals x squared. And then we square root both sides. So x is equal to 3.17. And that's our answer there. All right, and then our last one for as far as solving is when you set them equal to each other. Again, when they're set equal, it doesn't matter if it says log or natural log, it's same process. X minus 5 is equal to 3x plus 10 because our natural logs canceled each other out. So I'm going to subtract x to both sides. So that gives me negative 5 equals 2x minus 10. I'm going to add 10 to both sides. So that's going to give me 5 equals 2x divided by 2. And you can either leave it as 5 halves or you can put it as a decimal, which is 2.5. All right. And then the last thing we talked about in Unit 2 was word problems. We talked about compound interest and compounding continuously problems. So like, for example, number 26 is how much money would be in an account after 9 years that pays 5% interest compounded semi-annually if the initial investment is $500. So remember, when it says semi-annually, annually, monthly, quarterly, all that good stuff, that's that compound interest equation, which is A equals P times 1 plus R over N to the N times T formula. Okay, so here we're going to plug in the information. We want to know how much our final amount's going to be if we invest $500. Our rate is 5%. And so remember, you turn 5% into a decimal, which will be 0.05. It says semi-annually, which means that my end value is 2. And then it says my time is 9 years. Okay? Now remember, when we did this, I told you don't try to plug it all into your calculator all at one time. Simplify the small things. So that becomes 500 times 1 plus 0.05 divided by 2 is 0.025 to the 18th power. Now that you can plug completely into the calculator. Which gives us $779.83. Remember, we're talking about money in this problem, which means that you have to use 2 decimal places. All right, I'm going to skip 27 and come back to it. Number 28 says find the accumulated value of an investment at $2,000 at 4% compounded continuously for 8 years. So every time you see the word continuously, that means you're using the equation A equals P times E to the RT. Okay, so we want to know what our final amount's going to be. We're investing $2,000 at a rate of 4%, so 0.04 times 8, because we're talking about 8 years. And that one you can plug straight into the calculator. 2,000 times E to the 0.04 times 8, which gives me $2,754.26. All right. So now coming back to number 27, it says Ajane invests $750 at 10% APR compounded semi-annually. How long will it take her to double her money? So this time we're not looking for the final amount. We want to know how long it will take her to double her money. So we need to find what our T value is. And because it says semi-annually, that means I'm going to use this equation up here that we previously used. Okay, we need to know what our A value is. Well, we want to double our money. So 750 times 2 means that we want a final amount of $1,500. So A is going to be equal to 1,500 My principal is $750 times 1 plus my rate is 10%, so that's 0.10. It says semi-annually, which means that's twice a year, to the 2 times t. We don't know what our time says. We're going to leave it as t, or you can write it down as x, whatever. All right, and so then you start solving. So first thing I'm going to do is I'm going to simplify some of the small stuff. So I'm going to simplify my 0.10 divided by 2, and that gives me 0.05. So that's 1,500 equals 750 times, and that's 1 plus that, so that's just 1.05 to the 2t power. All right, so then I'm going to solve by dividing by 750 to both sides. And that's going to give me 2, I'm going to set it equal to 2. 2 equals 1.05 to the 2t power. Okay, so now we've got an exponential problem we need to solve, so the thing we have to do next is convert it to logarithmic form. So that becomes log base 1.05 of 2 is equal to 2t. And that's that part that you plug in the calculator. So we'll do log of 2 divided by log of 1.05, which will give us 14.2 equals 2t. And we'll divide by 2, which will give us 7.1 equals t. And so some problems, depending on whether it's online or in class or whatever, usually with time you're going to use whole numbers. So your final answer would either be 7 or 8 years, depending on how you round, and if it's a multiple choice problem, how they give it to you. But 7.1 is what I will take for that one. Okay? And so then my last problem is Aja invests $750 at 4% APR compounded continuously. How long will it take her to double her money? So again, we're looking for time, but this time we're using the continuously problem. Okay? And again, we want to double her money, so that means we got $1,500 is equal to 750 times e to the 0.04, because that's my rate, times our time. Okay? So we go straight into solving because there's nothing to simplify or combine, so we'll divide by 750. So that gives me 2 equals e to the 0.04t. Now another way to rewrite this is just switching the sides, so it's something you're used to seeing. Equals 2. So now we need to convert that to natural log form. So that becomes natural log of 2 is equal to 0.04t. And so again, we'll plug in natural log of 2 in the calculator. So that's 0.69 equals 0.04t. And we'll divide by 0.04 to both sides. And that'll give me 17.3 equals t. So it's going to take a little over 17 years for Aja to double her money. So if you look comparatively to Ajane at number 27, it'll take a lot longer if you're compounding continuously versus compounding semi-annually. All right, so that is the end of the review for Unit 2. For the classwork, again, you're going to practice with your solving. Some of the problems for me didn't print out right, but if you have any issues with being able to read the problems when you print them out, they should be okay online. Just let me know if you have questions on that. And then on the back side, you're going to solve some more and then finish up doing a couple of word problems. Okay, again, if you have questions, comments, concerns, let me know and I'll answer them. All right.